Hi. I think we'll get started. Tonight is the last lecture of our series this year, and I'm pleased that it'll be given by Heather Roberge, someone who's visited CCA previously both as a lecturer here a number of years ago and also as a critic for our final reviews. Heather is the founder and principal of Murmur, an innovative and very forward-thinking practice that seeks to expand the public role of architecture through the spatial, structural, and atmospheric potential of emerging digital design and manufacturing techniques. Her research focuses on the effective implications of contemporary surfaces, with particular interest in formal and material experimentation that engage the senses and produces layered sensorial effects. Murmur's current projects include the Vortex House in Malibu, California, and several residences under development in Los Angeles. And previous to the establishment of Murmur, Heather was also the co-principal of Gnuform, a practice that produced a number of significant projects, including Purple Haze, a proposal for PS1, MoMA's Young Architects program. Heather's work has received many design awards, and it's been published in a number of journals and books, including A+U, Praxis, Metropolis, ID, Architectural Record, 30, 90, and Log, among others. Her work and writing has also been included in Soft Space, Crib Sheets, Digital Fabrications, and Matter, Material Processes and Architectural Production. In 2011, Murmur's Succulent House was awarded an AIA LA Next LA Design Award. It's a little bit redundant there. Her work has been featured in many exhibitions, including the Beijing Biennale on emerging talents, emerging technologies, and Gnuform, hairstyle, patterns, cases in synthetic intelligence, temporalism, and matters of sensation. Heather is also a very dedicated educator within architecture. She's the Associate Vice Chair of the Department of Architecture and Urban Design at UCLA, where she teaches graduate courses in design and digital fabrication, and she's also the director of the undergraduate program in architectural studies. In addition to UCLA, Heather has also has taught previously at Pratt, RPI, WashU, Ohio State University, and has also lectured and been a visiting critic at many prominent institutions. I'm really happy Heather is here as our final closing lecture. Please join me in welcoming Heather Roberge.
Thank you for having me. It's really good to be back. I was hoping that I had done some new things since I lectured here in '06 and was grateful that I had. I wasn't quite sure. Time is a big blur when you teach and practice. So because I spend a lot of time teaching and practicing, and I'm finding myself tackling problems from the studio in practice and even more frequently trying to bring practice into the studio, I thought that I would start by laying out just a brief set of points that was part of Material Matters, or Matter Material Processes, which was a book that came out recently. And the subject of this text is called Sheet Logics. And this is something that has been started to be thought about in the context of advanced topic studios at UCLA, as well as a series of tech seminars. And I found that topic changing the way we were approaching design problems in the office. So this is a kind of example of the way in which research thinking in the academy impacts the way in which we're practicing. So before I go there, so Sheet Logics is essentially a series of points which is looking to understand the role of changes in craft and and the role that those changes in craft play in design research and in altering disciplinary problems. So I was one of a generation of students of architecture who was educated right on the tail end of analog processes and the very beginning of digital processes, and as a result began teaching early, too early really, and did many digital experiments which were grappling with new animation techniques and digital description and trying to understand the way in which it would alter the potential of design. This, in a way, is a series of points that's not so dissimilar from the early research that we did, though it basically is a series of observations about the way in which digital models have transformed the way we conceive of three-dimensional problems, and it lays out a design framework that I call sheet logics, which is a framework which attempts to draw the organizational and cosmetic together. I've replaced the term surface with sheet because it refers to both topology and substance, to geometry and material. Surface, on the other hand, refers to the exterior boundary of an object. It's defined as a part of a whole. Sheets contain parts but can expand and respond to contingency without losing their organizational coherence. So this is a series of speculations about the ways in which sheets open up disciplinary research that's both organizational and cosmetic. Sheets avoid the solid logics typically associated with mass. Unlike surfaces, sheets need not conform to the organizational constraints of a solid. Figure-ground relationships emerge from solid logics, while sheets distribute events across a field rather than adjacent to or across a threshold. So I have two figures here. One is the Jussieu Library competition by OMA, where programs distributed using the logic of sheets, and an interior kind of urban environment is made. The edge of the floor plate in this case is provisional. What matters instead is the sequence of events that unroll along the sheet's length. This is in contrast to their competition entry from '89 for the Très Grande Bibliothèque, where the entire mass of the project is understood as a solid. Quite literally, it's a series of stacks, and the programmatic elements are carved figures that produce voids that float in the stacks. Sheet logics unseat figure ground as the chief organizing principle of planning and massing. Figuration emerges across a field and at scales both small and large. Figure-figure and ground-ground relationships are possible. Here's an early rendering of the Dubai Opera House by Zaha Hadid. The fundamental design concerns of massing are part of early sheet production rather than emerging from the conventions of material assembly. So formal questions associated with massing require novel approaches. That means the relationship of a mass to the ground, its terminations, its corner conditions, etc. These tropes have been developed for solid logics, and they provide insufficient solutions to questions of how a sheet might meet the sky, meet the ground, etc. Other questions of sheet description at apertures, changes in orientation, or changes in material are also left unanswered by convention. So this is an example of a sheet, what I would call a sheet logic project, Sana's Rolex Learning Center in Switzerland, where the sheets here are where the building's organizational logic is a kind of test bed for drawing different relationships to the ground plane. Here's another example, which is kind of strangely characterized by me as a Sheet Logics project. This is the Prada store in Tokyo by Herzog and Demeron. And this one I describe as a sheet because it's basically conceived of as an unrolled pattern. And that pattern and its small-scale geometric logic has to renegotiate and alter the ground plane around it in order to maintain its interior coherence. With sheets, there is no hierarchy of relationships between master plan, building organization, ornament, and detail. These formally distinct and hierarchical phases of design dissolve. Building organization and ornament may be generated simultaneously, and ornament is free to be distributed across the sheet as intensities within it. This is an example of a project where the detail scale and as well as some tropes of mass, such as the definition of entry and the relationship of a building to its various edge conditions, is handled through Sheet Logics by Frank Gehry. This is the Experience Music project in Seattle. Sheets are featureless, boundless, and scaleless until operated upon and deployed. So sheets develop features as a result of careful geometric operations. Boundaries emerge as a registration of internal relationships or may be drawn in response to context, program, or intent. Scale emerges from contextual and programmatic feedback when sheets are deployed in relation to site. This is a project by Greg Lynn, Arc of the World Museum, where he uses a series of sheets that are rolled up to produce a variety of spatial types, sort of covered exterior space rendered as canopy, niche-like space that produces a series of peripheral galleries as well as the entire building mass. Minor operations have major formal repercussions. The ease with which operations produce sheet behavior allows the study of versions. Versions are related families of design work that allow differences and similarities of each operation to be evaluated and built upon. Sheets require tectonic inventiveness. This is an old Gnuform project for the Queen's Museum of Art expansion strategy. So sheets, rather than developing a spatial diagram with a tectonic solution, sheets basically distribute material in space, and the tectonics have to be evaluated on a local scale. So rather than producing abstract ordered fields of geometry that downplay materiality, sheets provide form-active tectonic potential without reducing the solution to a single structural system. This allows secondary systems to step in as sheets require them. Sheets confound material expectations. They imbue surfaces with material qualities rarely associated with architectural production. Surfaces are rendered material rather than abstract. Sheets exhibit posture, which results from its material behaviors. Sheets may drape, recline, billow, etc., depending on their weight and material properties. So this is an example of a model by Gehry Partners. The IAC headquarters was modeled in a series of materials. This one is mylar. There were mirrored mylar studies. And you can see in later translations of the architectural model to the physical construction, the way in which qualities from the model migrate into the full-scale product. Sheets encourage the commingling of the representational and the material. Sheets are the primary site of digital description. They operate as the backgrounds of drawings, the primary visual material in three-dimensional modelers, and the products of numerically controlled machines. The commingling of the representational and the material allows the synthetic to alter the real. When digital information inhabits physical environments, the mixture can produce a new set of synthetic qualities. This is the actual translation of that earlier Mylar model in the IAC building in New York. Sheets move beyond the single surface problem, that problem that keeps rearing its ugly head in architecture schools. Your teachers can explain that to you. Scissors can have their way with sheets. This is Reiser Umamoto's West Side competition, where sheets were manipulated using cutting operations at a variety of scales. At fine scales, cutting alters sheet materiality using techniques like perforation, striation. At medium scales, cutting manipulates profile and silhouette, and at large scales, cutting produces particular sheet boundaries that deal with urban or local site conditions. Sheets are sided. This is a competition entry by Future Systems for the Czech National Library. Unlike solids that are conceptualized as of the same medium throughout, sheets have sides. This sidedness may be exploited to condition different atmospheres around it. This is often choreographed by the application of graphic material. Graphic material readily adheres to sheets. Cosmetic effects are possible when deploying sheet logics. Graphic material, including color, texture, pattern, and imagery, is easily introduced to sheets using a variety of technologies. Sheets expand the expressive and performative capacity of seams. Rather than reluctantly accepting seams as a byproduct of assembly constraints, sheets foreground the capacity of seams to perform at larger scales. Seams can radically alter silhouette using techniques borrowed from something like garment construction, which I'll talk about a little bit later. Seams can tightly tailor sheets with careful pattern making techniques or expand them using the additional inserted material. Seams therefore manage and distribute surface area in highly particular and controlled ways. This is an image of a project, an installation project done in the office. So now I'm going to show you a few projects, both from practice and teaching, which have been working on this, working within this framework of sheet logics to greater and lesser degrees. We'll start with practice. So this is a project. I'm going to show you a project that's under construction in Malibu. It's called the Vortex House. The site for the project is right below this wildfire that was burning about 6 months before we started construction. The house is kind of hidden in the trees, kind of right in the middle of this image, and the bald part of the hill is where the fire was in the previous image. The site is 1,000 feet above the PCH with 200-degree views of the ocean, and it's being developed as a rebuild project, a disaster rebuild project. So the site is extraordinarily difficult to economically develop at this time, but there was a house on the site previously. So if it's possible to develop the site using conventional foundations, if you're willing to jump through something like 2,000 hoops, which I've been doing for several years. The site plan is here. The project is a 5-sided mass that's developed underneath a sculptural roof plane. So the sheet in this case is the plane of the roof that you see, the center of which is a courtyard. And to the south, which is down, is the 200-degree view of the ocean. To the north is the continued rise in topography to the ridgeline. So the project's ambition lies in its dramatic spatial modulation and the saturation of its interior with the visual and geometric material of the surrounding site, rather than understand the views as a way to release the interior to the exterior. The surrounding geometric and topographic features are drawn into the interior to condition its atmosphere. Artificial and natural geometries are characterized as of the same fluid medium and the house a vortex into which the material is drawn. So I kind of show this Lautner house, the Arango house in Acapulco, as an example of what the project isn't intending to do, though I think it shares some characteristics with this particular project. In the Arango house, you arrive at the top level. There's an exterior entertaining terrace on the upper level, and underneath that terrace, the private quarters of the house are kind of nestled into the house. So the view is captured through a canopy above, and the living space, the formal in kind of conditioned living space, is underneath. And the house basically produces a picture window, a panoramic picture window of the coastline. In this project, there's actually a desire to fuse the space of the Arango canopy and the private spaces into one environment. So you can see here, this is a view from the northeast, kind of above. So this is a false digital rendering. The ocean's not nearly as close. You enter along the upper right of the screen, and there's one place where the roof extends beyond the perimeter, the wall perimeter of the house, and you move into the house underneath the sculptural roof plane. And then every room is given at least 2 faces of exposure to the surrounding landscape, which means that every room feels a little bit like a pavilion underneath the canopy and set into the landscape. And then to the south here is a covered patio, which is permissible space. It extends the living space, and it's a kind of inclusion in the overall mass of the project. There are many ways in which the courtyard works to kind of act literally as a vortex. There's a lot of natural daylighting or natural ventilation strategies which are illustrated here, but the courtyard also does a lot to produce more views of the landscape beyond than just that which you can capture on the exterior envelope. So these are some of the exterior envelope views. And this is a section which shows the way in which the space on the interior is open to the plane of the roof. So the ceilings are always moving to meet the roof, and every room has kind of multiple focus points and also a variable ceiling height. So on the right are a series of views of the space where you can see the views of the landscape beyond, and the way in which there's a kind of correlation between the rise and fall of the ceiling, the rise and fall of the head and sills of the aperture, and the landscape beyond. And all of this is achieved by basically a hybrid steel frame and timber construction, so that all of the dead load of the house is taken through the steel frame, and all of the shear is managed by the wood framing. So I'm just going to go through quickly to show you some of the construction images. We're just about 2 months from the completion of construction. I have a series of sort of ratty images of the construction site, but you can get a sense of the environment in which the house is located. This is a sequence through the entry, where the one location where the roof extends beyond the walls, and there's a kind of slip into the front entry. So when you approach, you don't see the ocean view, but as you make your way to the front door, you can see through to the ocean beyond. This is one of the views that kind of looks like an interior rendering on the top there. And this is the ceiling plane coming together. You can see it extending out into the patio. And there's one location here where the geometry of the sheet is not idealized for the distribution of load to the perimeter of the building. And so there's this one beam that kind of slips out underneath the ceiling plane and basically transfers load that accumulates at this high point above the living room. This is the view back toward the entry. You can see the canyon beyond, and then to your right is the courtyard. And this is the view to the southwest of the Malibu Pier and the landscape beyond. This is to the southeast. You see more ocean there. And right now, this is the kind of pre-finish coat for the stucco. The roof is zinc. A lot of the edges are really crisp and sharp. And the roof is managing rainwater. It's also dealing with the structural load, and then it's rising and falling to manipulate the space on the interior. So in terms of what the courtyard does, once you walk in, you have a view toward the courtyard, and you can see through the courtyard out into the ocean. And then when you turn back around, you walk to the bedrooms in the house, and you move around the courtyard. So this is a very tiny house, so the spaces of the house are not nearly as compressed because you have a series of views to the landscape through that courtyard. And then when you arrive at the master bedroom, then you have another view of the ocean and a view back to the living room to the right. So the next house I want to show, which will go more quickly than that one, is called the Succulent House. This house was designed as a design proposition for a book called Making a Case that was recently published by 306090. And the editors of that book asked a series of architects to produce a design project or writing that responded to a contemporary crisis in the American house or American housing. And so our proposal addressed what we called the crisis of identity. And we made the following argument. The contemporary American house is experiencing a deepening crisis of identity in this era of growing environmentalism. This identity crisis began nearly 50 years ago with the end of the case study house program and the rapid acceleration of suburbanization. The discipline of architecture never regained its footing in the context of American housing, as housing became a product subject to the efficiencies and economics of mass manufacture. The impact of suburban sprawl on energy, water, and transportation infrastructure was largely overlooked until its geographic consequences were firmly in place. The widespread growth of environmentalism has done little to assert a new identity for the American house. Whether produced individually or en masse, the American house remains a mixture of old forms, updated equipment, and engineered building products that mimic long-abandoned methods of construction and long-discarded lifestyles. This critique applies as much to the tract home as to the dwell-modern, mid-century remix. Neither solution comprehensively addresses changing societal values or contributes significantly to contemporary design culture. An appreciable shift is underway as a new audience of environmentally concerned citizens gathers. While thus far this audience has embraced environmentally friendly product and equipment upgrades like those shown on the left, this approach is insufficient as its impact on sustainable development is minor and its rate of change too slow. We believe growing environmentalism should be met with design ingenuity, not product specification. A lasting contribution to sustainable development or the discipline is impossible when underperforming architectural and urban organizations are simply reproduced using green-branded products. So our proposal addresses the pressing global issue of fresh water quality and supply as but one possible force to drive design ingenuity and improve environmental performance. Ultimately, this approach allows us to speculate on the organizational, spatial, and atmospheric potential of water collection on the American house. So it was our hope that by doing analysis of rainwater cycles, gray water potential, the storage of water for the use in gray water systems, that we would be able to produce a prototypical house that could be reworked in different climates in America. Ultimately, we only did one, and we collected a lot of data, but we designed one project for Chicago, and the house is what you'll see now, called the Succulent House. It's sited on a prototypical urban parcel of 50 by 110 feet. This is a common lot size in LA and in other cities, especially in the inner beltways. And we selected this site because we anticipate continuing trends toward inner beltway reurbanization. Organizationally, the roof area of the house is divided in two, and its area maximized for water collection, storage, and distribution. So the roof planes are inverted, and they collect water at their centers. The program of the house is distributed around those cores. So in the back, we have a winter garden, which is adjacent to a master bedroom and kitchen. In the front, at the living room and family room, we have rainwater storage bladders that are wrapped by a bedroom above and living space below. This is what these look like in section. The bladders are heat-welded vinyl bladders, which expand as water is stored. And so when you have rainwater, like its namesake plant, the bladders exhibit succulence in times of increased water supply. In times of low supply, the bladders are loose and drapery-like. These are some of the images of the interior. Someone called to ask if they could tour the house, but since you're all architects, you know that wouldn't be possible. This project is called Ultramarine. It was commissioned by the executive director of the Lace Gallery. It's a contemporary art exhibition space in the heart of Hollywood. The challenge to me was to transform the main gallery space into a public plaza for summer programming. The gallery is located right on Hollywood Boulevard, right along the Hollywood Walk of Fame. So ultramarine is an immersive environment of iridescent color, a massive cloud of delicate undulations. The title refers both to the color of the piece and to its meaning beyond the sea. The installation produces the physical sensation one feels when gazing at a cool body of water. Like the sea, its surface appears to be in a constant state of flux as the fabric curls and drapes in unexpected ways. Conceptually, ultramarine produces an abstracted synthetic vision of the Southern California landscape. It is at once the clear blue sky, the shimmering rhythmic surface of the sea, and a deep, glistening swimming pool, all of which were the things that I thought were shared public experiences in Los Angeles. The piece was conceived of digitally but produced manually using dressmaking techniques to alter the lengths of the top and bottom of a series of fabric sheets. Long sheets of contoured fabric were darted and stitched to choreograph both the general underbelly of the piece as well as its local flounce. Detailed studies of the line work and surface manipulations inspired the design approach and helped calibrate the effects to the desired scale, transforming the empty room into an environment saturated with color and movement. We did all of this with analog techniques because it was inexpensive and fast. So our only digital assistance was that of the digital model and large-scale plotters. But other than that, we were like 5 dressmakers lying on the gallery floor and putting this together. This is a competition that we did in the office last summer. It's a competition that we worked on following a series of studios at UCLA that I called Fabric Fantasies. And essentially the students were working with kind of swatches of fabric, applying dressmaking techniques, and sort of slowly producing figuration across fabric surfaces. And so using some of what we learned in that studio, we produced this competition entry for the New Taipei City Museum of Art. You can see here that we did a series of diagrams that were our underlying geometric logic for the project. We had a series of kind of cubic masses that we wrapped with surface, and those surfaces could be manipulated in the following ways. Basically, they were subdivided, they could be pushed in, pulled out, sliced, flipped up, or joined. And one of the reasons why we kind of wanted to assign a logic of parts to the project is because it was quite a large project with many different types of programmatic centers, from a children's museum to the Contemporary Art Museum to a research library and other things. So to the north on this particular site plan up is the city fabric of New Taipei City. To the south is a river, and this is essentially a floodplain that they are attempting to develop a series of kind of cultural attractions. So they have a ceramic park, and they're developing this contemporary art museum. So we used the surfaces of the different constituent parts of the project to extend the kind of the spatial types that we could get at the first and second levels of the museum, and then we allowed a kind of more standard large plates of gallery to stack up above that. But what it allows us to do is really manipulate the main entry level, the level just above that, and the relationship of the building to the landscape. So there's kind of a large, busy multi-lane road that rides right by the site, and so we're able to berm and sort of use the surface of the building to block noise and sound and views from the exterior, while at the interior we produce this art plaza where the lobby, restaurants, stores, bookstores are located along this level. And then you see in the middle of this image the way in which the kind of cloak of the scheme lifts up and touches another area of surface on the other side, and it gives us a column-free space where we're able to push all the structural components to the exterior of the project and open up the lowest level of the building in between the building masses. So this is just a kind of simple program diagram. The sheets were also helpful in organizing vehicular traffic and light rail, which were also part of the competition brief. So this is the ground level of the scheme. The rail line comes in at the bottom, the art plaza's in the middle toward the right, and the extended surfaces that berm into the landscape make space for large footprint parts of the program, like an auditorium, all the loading, restaurant, and lobby is right in the center of the image. And this is the first floor plan above, so you can start to see what the way the surfaces are being slid and pulled off of the mass. And then the plans just keep going to the top, getting kind of more, the surfaces get more taut as you make your way up. And one of our desires for the project was to introduce color and do it through the use of a kind of two-sided ceramic panel, a glazed ceramic panel that has lenticular effects. So as you move relative to the surface will change colors as you see more of one edge than another. This is the one of the main sections through the building. The lobby's at the center. You can see that when the surfaces are pulled out or flipped up, they actually depart from the superstructure of the building, which to us was very interesting because it meant that along its entire length, the sheets for this scheme would have to take on tectonic and sort of load-bearing capacity in their own right. They're no longer just dealing with wind load and self-weight, but they have to take up spanning. So the character of the surface will vary from the top to the bottom. And this is just a detail of what's happening there. And then interior renderings. On the right is the lobby space looking back toward the art plaza. And here is a second floor escalator, which is making its way back down to the gallery. So I'm just going to show you one more thing. Actually, I'll just show you something kind of new. This will be the last thing. So over the past few years in tech seminar teaching, I have been trying to work out a little bit what the value of excessive digital information being layered onto surfaces might be, and have written a little bit about it. And these are some images that are kind of uniquely from Southern California industry, namely the entertainment industry, toy industry, and we also have automotive and aerospace industries. So this image is just kind of a stand-in to show the way in which, with digital tools, you're able to hybridize different feature sets to produce new environments. So in this case, James Cameron takes the world of the deep sea and the world of the forest and produces a kind of uncanny new world that we know how to inhabit because we recognize the stuff of those two worlds from our own experience. These are some other selected products of Southern California culture. The BMW automobile, a Boeing aircraft, the Bratz dolls. All of these are just examples of the way in which cosmetics and geometry and synthetic conditions come together to generate cultural products. So at UCLA, when working with an interest in craft at the scale of the architectural model, I like to introduce students to techniques that are analog so that they have an idea about what they want to accomplish in a digital model. So this is an unfolded model of some students, and they basically produced a armature, a kind of mannequin for their project in a digital environment, and then they used 2D pattern making, like a dressmaker, to produce the surfaces for that mannequin, and then they were able to put that back together on the mannequin. So I don't know if this is a good idea, but I think this is kind of an interesting video. So they basically had all of the surfaces of the model completely developed. They knew the surface area associated with each part of the model, and then they basically dressed this mannequin with their scheme. I want to turn it off. So that's one of the ways in which we work on craft. The other way is looking at the role of craft in building assembly. So this is a sample project from a tech seminar where the students used in-house thermoforming of plastic to simulate the thermoforming of an aluminum alloy that an aerospace company in Riverside, California uses. So we developed a technique for applying ornament, for determining the number of panel types we could have, and designing the connection systems for that in order to produce rain screen systems. So my students have done something like 20 of these. This is just one example. And then last year we developed, kind of out of the findings of the tech seminar sequence, a core studio, which we call Tech Core. And the students developed half-scale prototypes of facade systems that they designed either using polymers, concrete, or metals. And so I was going to show you two of those. To the very right of this image is one project that I found really interesting. It basically hybridizes pan-formed concrete systems and fabric-formed concrete systems into a hybrid system. So the cells, all the pans are identical, and the students developed a kind of malleable gasket in between those pans that would allow them to produce large precast panels of varying shapes. So this is a sample of one of those, and it allows them to basically get undulation across the facade because they can, using the economy of the pan, still produce unique parts across the assembly system. And then this is a rendering, a kind of schematic rendering of a series of students who thermoformed acrylic and did a kind of double skin acrylic system, and also applied a kind of graphic treatment to manage light for this new facade for a community center in LA. So I guess that will be it. Thank you. Sure.
Oh, wait, there you go.
Looking at this, you've been talking about sheets versus systems, and a lot of the characteristics of sheets are almost landscape-like in a way. I was wondering, because I am in that science fiction, I was wondering if there's a way of translating the idea of a sheet vertically in terms of it as space rather than being the generic wrapper in a way. So I was wondering what your take was on that.
Well, you're in a skyscraper studio. I've never had the pleasure, actually the horror of designing a skyscraper. I think that would be extraordinarily hard, maybe because of my sensibilities. But one of my students who did the unfolded kind of garment for his building immediately went to another studio and did a tower project using sheets. And he, what would I say? I mean, he produced a series of features that kind of ran up the elevation of the building and produced a kind of cascading impact on the floor plate. So if you looked at something like Foster's Gherkin Tower in London, there's a series of geometric devices that run around, diagonally up and around the building, and there are a series of spaces that are actually tracking that device on the exterior. So that's an example where the logic of the exterior has an impact on the space-making strategy on the interior. In the new Taipei City Art Museum, it's only a mid-rise project, right? It only goes up to 6 floors, but I'm always interested in how by setting up a different relationship between the edge of the slab and the surface of the building. You can generate space between the surface and the kind of superstructure of the building. And in doing that, you produce tectonic and assembly problems in the surface, which changes the way one experiences it. So a surface could go from really thin and kind of a series of panel, like stick and panel system that would move to a form-active kind of folded plate system where it needs extra depth. So I think there's a lot you can do, though I think the taller you build, obviously the demands on the skin are going to change a lot. Other questions?
Mm-hmm. How significant are software tools in visualization and application your curriculum in this digital world you're describing?
Well, I think we use software for everything. I mean, it is basic. It's the primary tool, though the students, depending on what project I were to show you, the students are using whatever tool is necessary for the solving of a problem they have. So they might pick up Grasshopper to solve this problem, and they'll model, we'll model something on the succulent house in Maya because we can't model it another way. But we can also write little machines in Rhino in kind of low-tech ways to manage things. So I tend to take the path of least resistance when it comes to technology and use whatever I need to use to solve that particular problem. But I think students these days are really savvy about knowing which tool is necessary to solve what kind of problem, and they move fluidly between platforms and software packages, and the same thing happens in the office, though. Because I'm trying to, I'm interested in building, so I'm also interested in developing descriptive techniques that can be achieved with economy in mind, so that I can produce a large wall, produce something in aluminum instead of plastic, produce an architectural project, and move out of installation production. So, I think it's amazing to me how quickly and while trying to be very careful, I can easily design something that will cost $1 million. It just goes like that. And so when you're doing a building with all of its requisite parts and foundations and everything else, it goes really quickly. So I'm, trying to teach students about geometric tricks you can use to actually pull things off. So if labor costs, it's not free, then how will you, and molds are not free and materials not free, how will you still get to do something you want to do?
One of the slides you showed talked about the difference between a solid and a sheet transformational diagram. And I was kind of thinking when I saw that about how the way that you're teaching is how you'd actually have to reformulate almost an entire response to that pedagogically in how you're teaching. So how do you, at the earliest levels, get students to think about that as a kind of logic? This is so different than the way how cities have been made, especially in Los Angeles. You're reformulating it from sheets or skins or layers.
It's pretty easy because students move kind of linearly, so they make the plates first, and they're so. I think I like to have students start with physical models, because I find that digital models are better if you have an ambition for them before you set to work. And so, and one of the things that I think teaching the Between the Sheets class, which was all about the rain screen systems, is it made me realize the inability of digital modeling techniques to manage surface area and to really understand when you're radically expanding surface area and when you're shrinking it. So I saw the Experience Music project and realized that there were all these scales at which surface area manipulation was happening, and started dabbling in garment making. And what I love about that is you'd never sit down at your computer and decide you want to produce flounce, or you want to produce a kind of tailored camber that you can get in a bodice. But if you do that in a physical model, then you can figure out exactly how to do it in a digital model, but you'll know exactly how much surface area has been removed and how the silhouette is behaving in response to that. So the students like it, because I think when you open up, Rhino and you try to figure out what to make, you need to have a desire and an ambition before you can figure out what to do there. So it's easy to teach them that.
I'm curious on the first house you showed, how you had that beam coming through. Mm-hmm. I'm just wondering how your office, your design development responded to that, because that must have been an engineering addition, or was that always part of your process?
No, I knew that there would be a beam there. I mean, all of the, a lot of the high points of the roof are around the courtyard, and then a couple at the exterior of the house. And I knew that if I did that at that point, that I would either need a column because of the way things were going to happen, or I'd need to transfer the load over that, out of that point. And I actually like it because it's basically revealing the way in which the geometry is related to the structural system. So there are only two places where the steel pops out of the surfaces of the project. One's at the patio, which I could probably do without. That's the one that engineering gave me. But the other one I like because it basically is a glimpse into what's happening behind all of the more abstract surfaces of the project. I mean, I've been practicing a while, so and tectonics is something that I'm really interested in. So I'm usually not surprised by what comes up. And that's just a place where you need a second strategy in order to make that particular surface work. And we sort of foregrounded space and rainwater, roof water drainage, and accepted that the tectonics would just solve that condition.
Do you mind elaborating on how you and your team came to the conclusion of that expanding and contracting water sac, and how you justify that solves an American household crisis?
Well, remember that the crisis is a crisis of identity, so it's about the house basically using new equipment and new building materials to reproduce old images of the American house, and I'd say old spatial models. So in Los Angeles, for example, you can drive around Santa Monica and you'll see a mid-century house that's been put on a Xerox machine and blown up 2.5 times. So the roof, which used to be this thick, for one set of environmental pressures is now 24 inches thick, and a space that used to be 8 feet high is now 16 feet high. So you have to understand that the project is really an ideas project, and what we were interested in is by having a kind of supple rainwater storage system, you would be able to see quite literally how much water you were using, and the rhythms of rainwater cycles would be part of your daily life. So it changes the kind of reflections off surfaces and literally the space of the room. So like I said, it's an idea, and the first thing my 9-year-old did was ask me to put a little person with a pin right next to it in the rendering, because he's mischievous like that. So we thought of the name of the project first, that it would be the succulent house, and that it would be this thing that would make one aware of rainwater use and collection and the kind of water deficits that we're facing. So it's like a Hollywood movie. It doesn't have to be real. Thank you.